Good afternoon, everybody. Welcome to another exciting Wednesday afternoon of Chem 170 with your host, me, Dr. White. Now, important announcement. A week from today will be test number 2. Unfortunately, I haven't put up the information for test number 2, but I can do the following. And the following is, and by Friday, I'll have this posted as an announcement and it'll be sent out to you as an email. All right, test number 2 will cover alcohols, thiols, ethers, reactions of ethylene oxide and aldehydes and ketones. You can see I'm a lazy organic chemist. I don't write the words out. I use shorthand. So it'll cover alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. Now, we've done all the problem set except for the aldehydes and ketones. Next Monday, I will go through the problem set for aldehydes and ketones. If you notice, it's a long one because there's a lot in there. Next Monday, I will also do my world famous review for the next test, test number 2. Now, I don't have, if I remember correctly, historically, test number 2 is about 9 pages. Again, if you've done the practice problems, you will have no problem with test number 2. By the way, that means you've done them correctly. Hopefully you, and I don't know the exact point breakdown. But historically, it's been about 70% reactions, about 35%, or almost give or take a little, and about 10%. That adds up to 115. So this is probably one of these is a little lower, but the majority of the tests, about 65%, let's make this 65, will be reactions. And there'll be 4 synthesis problems, 3 or 4. But the bulk will be give the organic product or products. And general knowledge are things you should know about. Speaking about knowing about, did any of you happen to drive by a gas station and see where it says on the pump, at least in the Chicagoland area, I think it's the same throughout the United States, that this gasoline contains up to 10% ethanol, and ethanol is an alcohol? Did you think about that? Did you happen to go into a liquor store? Not that I'm implying you should ever purchase liquor, but, or if you went into a supermarket that sells hard spirits, beer or wine, and you pick up a bottle of, say, Grey Goose or Absolute, and see this contains ethanol, which is an alcohol. Did you happen to pick up a bottle of rubbing alcohol and look at the label and says, ooh, it contains isopropyl alcohol, which is an alcohol? Did you do that? How about one last one? Did you pick up a bottle of nail polish remover and see it contains acetone, and acetone is a ketone? Remember, organic chemistry is all around you. I stole that from SpongeBob. And it won't hurt you to think about organic chemistry outside of lectures or when you're not watching me on Zoom, not Zoom, on YouTube while you're watching me on Zoom right now. All right. Any questions about upcoming test number 2? Like I said, by Saturday morning, if not earlier, I will send out an email and post an announcement with the actual pages and also the correct point breakdown. It'll be 105 points, which means I'm going to give you five, yes, 5 bonus points on test number 2. And we'll take it the same way you took test number 1, and that is on Wednesday afternoon next week. I'll email out the password for a PDF file that's password protected that will be posted next Tuesday afternoon in Black One School D2L. And you'll have until 11 a.m., give or take an hour, on Thursday to take test number 2 and then upload it. I like that special effects, upload it. Oh, that was hokey. I won't do that again. But anyways, you'll have, hold on, won't want to do it again. You'll have until Thursday, 11 or 12, 11 a.m., let's say, to upload your answers, just like test number 1. All right, now, a couple things about today. One, as I mentioned on Wednesday, I looked at the syllabus. I'm a week ahead because we already did the alcohols lab. So we're not going to do a lab today. There's no lab due next Wednesday because we're not doing one today, but the alcohol labs try and get in today or next couple of days. What I will do today is 2 things. One, go over some things in aldehydes and ketones that historically, aren't you glad I've taught this before once, twice, 3 times? I am. But anyways, that students have trouble with on test 2. We'll practice that. After that, we'll get into new functional group, new chapter time. And then we'll get into some of that and we'll get out early today, well before midnight. And don't forget, tonight from 6 to 7:15 on Zoom, if you have any questions, come to my office hours. That's a good place if you need any help whatsoever. Or if you just want to stop by and say hello to me, you can do that too. All right, let's go through a couple of reactions that students have trouble with on test 2. Everybody see my whiteboard? Thank you. All right, the first one I'd like to cover is this one. And again, I'm doing this because historically students have difficulty with the reactions I'll cover. And now, if our prime is a hydrogen, it's an aldehyde. If it's carbons, it's a ketone. Remember, carbonyl, carbon double bond to oxygen. Oops, I had some dirt on my, let's try this again. Yep, on my tablet. But here we have a carbonyl carbon. That's where all the fun is. Ketone or aldehyde, alcohol, acid catalyst. That's what H plus is. What's attached to the carbonyl carbon still is attached. And then you get this. And the carbon with the hydroxyl group is the carbon this oxygen is bonded to. Since we've gone over this, I'm going to let you do this one. Am I nice or what? Don't answer that. Give the organic product or products for the following 3 points each. Now, something I've been very lazy, so Okay, no, I'm not lazy. I'm gonna work you hard today. It's for your good, because you haven't figured out, I already know this stuff. And when you're done, don't forget, give me a thumbs up. All right, you're done. So I better get to work. Now, what do? You look for what's different, what's not carbon, what's not hydrogen. Oh, an oxygen bond to carbon. With hydrogen's carbon, that's an aldehyde. Could have been a ketone. What's this carbon? Oh, hydroxyl group on the carbon. Alcohol, acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it? R prime or H, and R double prime. Doesn't matter what you call R prime or R double prime. And now we have a hydroxyl group and oxygen and R from the alcohol. So this is my R prime, my R double prime, and my alcohol, my R. So carbonyl carbon becomes this carbon. R prime is hydrogen, and R double prime is the ethyl group. Remember, do you break carbon-carbon single bonds? No. And now my general reaction tells me I'll have a hydroxyl group on that carbon, oxygen. What's my R group here? From the alcohol, ethyl. And that's how you do it. I give everybody a chance to check their answer before I roll down the screen. Or roll up the screen, I guess. It moves up. And when you're done checking, give me a thumbs up. And let's do another one. And the question again is 3 points each. Give the organic product or products for the following. I hope all of you who are watching at home on YouTube, make sure you do these on your own too, like what the students are with me today. That was a public service announcement from your host, me, Dr. White. Thank you, Christiana. And we'll be patient and wait for everyone to finish. All right, everybody's finished. So how do you do this? You look for what's different. Anybody getting nightmares where I hear me saying or see me saying, you look for what's different? Well, guess what? When I look at a molecule at my level, I do the same thing. What's not carbon? What's not hydrogen? Should get your attention like that. It did. There's an oops, got so excited I wrote an extra line. You have an oxygen to this carbon, carbon's here and here. This is a ketone. It's in a ring, and Dr. White loves ketones and rings. I did my PhD thesis on those. And we have a ketone. It could have been a hydrogen, an aldehyde, it's not. We go over here, carbon, carbon, ooh, a hydroxyl group, oxygen with a hydrogen and a carbon, that's an alcohol. And we have acid catalyst. And what you get, keep your eye on the carbonyl carbon. What's attached to that, our prime, our double prime, is there. Remember, our prime could be hydrogen, in our case it's not. Then you have a hydroxyl group, oxygen, and my R. And now I'll go and do it. What's our prime and our double prime? Well, they're part of the ring and they're attached together. So here's this carbon here, which is this carbon. What's attached to it? My ring, and don't forget the methyl group. And it's this carbon right here, which is this one, and attached to that will be OH, then oxygen. What's my R group? Isopropyl. The carbon with the hydroxyl group will be the carbon attached to the oxygen in my hemiketal. And that's how you do it. And nice thing about, I'll be posting this video, you can always go back and watch it again. All right, now let's move on to another reaction. Unless anybody has any questions. Remember, there's no such thing as a dumb question or bad question in my universe. All right, next reaction I'd like to go over is this one. And now, if we take an aldehyde or ketone, when R prime is hydrogen, it's an aldehyde. When it's carbon, it's a ketone. And now, when we react not one, but two molecules or moles of alcohol with an acid, keep your eye on the carbonyl carbon. What's attached to it stays attached to it. Because do you break carbon-carbon single bonds? No, and I don't. Neither does Mother Nature. And neither should you. And hold on, I was thinking of the previous. And now you have two alcohols, so you're gonna have two oxygens, and each one has the R group from the alcohol on it. And we'll learn later on, Mother Nature uses these reactions, especially this one, to make starches, which are good things in life, especially the bad things. I said they're good, but they're dangerous things like Lay's potato chips, the onion and sour cream. Ouch. All right. And here's one for you to try. All right, my turn. And again, look for what's different. Ooh, an oxygen. What's not carbon? What's not hydrogen? Oxygen here to double bond to carbon with hydrogen and carbons. This is an aldehyde. It could have been a ketone. Ooh, the number 2 and carbon hydroxyl group, alcohol, acid catalyst. Keep your eye on the carbonyl carbon. What's attached to that? Our primer H and our double prime are still there. And because we have not one, but 2 alcohols, I should have only written 2 lines there, fix that, you get this OR, 2 of them, on the carbon that was the carbonyl carbon. So I'll call this R prime, this R double prime, and this R. Keep my eye on the carbonyl carbon, becomes this carbon, what's attached to it, R prime is hydrogen, R double prime is an isopropyl. Think about that. 6 months ago, would you have known what I meant when I said isopropyl? Now you do. I hope you do. And aren't you proud of everything you're learning? I am. And then I'll have 2 oxygens, and the R group is methyl. And that's how you do it. I'll hold on while people are checking their answer. And let's do another one. And here's another one for you to do. Give the organic product or products for the following reaction. All right, my turn. And if we look, what's different, what's not carbon, what's not hydrogen? Ooh, oxygen, double bond to carbon. Carbon's here and here. That's a ketone. Now, it could have been an aldehyde if the R prime was hydrogen, but it's not. So I'll call this R prime, R double prime. Now we come over, ooh, hydroxyl group on a carbon, alcohol. A second hydroxyl group on a carbon. And that's the same as 2 alcohols, but they're in the same molecule. And acetals, keep your eye on the carbonyl carbon. What's attached to it, R prime or hydrogen, and our double prime are still attached. And then I'll have two oxygens, and each one will have the R group from the alcohol, because we have two of them. Well, here we have the two of them are in the same molecule. So I'm going to write this carbon, which is this carbon. What's attached to it, R prime methyl. What's attached to it, R double prime ethyl. Now, this tells me I'm going to have two oxygens. And what's my R group? CH2. However, do you break carbon-carbon single bonds? No. So don't forget this bond is still there, which is this bond. For some reason, students forget to put that in there. I don't know why, but don't forget to put that in there, because you break carbon-carbon single bonds. No, so don't. And if you remember, I talked about this specific example. This is called ethylene glycol, which you don't need to know the name, but I do, so I'll tell you. And that has two alcohols in the same molecule. And that's what Dr. Herbert Stork invented to protect aldehydes and ketones. It's called putting on a protecting group. Everybody got this, looked at the answer now? All right, let's move on to another reaction. And I'm about to sneeze. Hold on. Excuse me. That was a slow motion, slow developing sneeze. Now, something I want to try differently that I think I'm going to try right now. And what I did, you know how sometimes my whiteboard freezes up on me? And what I try as an experiment, if I close it and delete everything and open up a new whiteboard, maybe it won't freeze on me. All right, let's look at the next reaction. Again, these are reactions I've already covered, but students have difficulty with them. So practice makes perfect, which means you'll get a good grade on the test. They'll make you happy, which will mean you've learned this, and that will make me happy. And let's look at this. This is called a hemiacetal, hemiketal. I'll never ask you the name. Now, R prime can be carbon or hydrogen. And what you do is look for what's different. Ooh, two oxygens single bonded to the same carbon. That's different. When you add acid and water, you get back the aldehyde or ketone you would have used to make that compound, plus the alcohol you would have used to make that compound. And again, keep your eye on this carbon with the two oxygens becomes the carbonyl carbon. And think of it as this reversing, making the hemiacetal or hemiketal. and you can write it H plus or water H plus. The order doesn't make a difference. And your turn. Oh, on a test, I would also do the following. See the plus sign there? That tells you get two products. That's my being nice to my students gift. Don't tell anybody I'm being nice. It'll ruin my image. I see one thumbs up, and we'll wait for everybody's thumb to come up. Or it can come down, or you can use any other. You can do the high sign like this. You miss it. That's from our gang. If you don't know our gang, look on YouTube. It's from the 1930s, but when I was a kid, it was always on TV. All right. What do we have that's different? Oxygen here to the same carbon. One's hydroxyl group, one's oxygen. Ooh, carbons. Then on that carbon, I have a hydrogen. It could have been carbons, but it's a hydrogen and more carbons. So if I look over here, I'll call this R prime, R double prime, and the carbon on the oxygen, R. And when you add acid and water, or water and acid, remember, you can find water and acid in your stomach. One of the great miracles of life to me is we all have cells in our body, in our stomach, that make hydrochloric acid, H plus. We'll talk more about that when we get into carbohydrates and proteins and fats and oils. And what you get back is the ketone or aldehyde you would have used to make that compound, plus the alcohol you would have used to make that compound. And if we look at this carbon here with the two oxygens becomes the carbonyl carbon, I'll draw that. What's attached to it? R prime, which is a hydrogen, R double prime, ethyl. And then my R group, the carbon bonded to the oxygen, is the carbon that will have the hydroxyl group. My R is 3 carbons, and the N carbon will have the hydroxyl group. And that's how you do it. All right, I think everybody's done copying. If not, scream, wait, don't move. And let's look at another reaction, similar. And now if we take this molecule and react it with acid and water, we have an acetal or ketal. And again, this is the only two places the reaction before, and this one where you have two oxygens single bonded to the same carbon atom. And here, keep your eye on that carbon. That will become double bond to oxygen. What's attached to it directly, our prime or hydrogen, will still be attached to it. and our double prime. And from this part, you'll get an alcohol. Now, in my tests, I say give the organic product or products. That's a better H. If you want to balance it and put a 2 there, you can. You don't have to. I wouldn't, but don't forget, did I tell you I'm this close to the person grading the test? Me. All right, let's take this reaction and try it out. And there's something for you to try. Remember, there are only 26 more shopping days till Halloween. Oh, I just thought of something sad. When I teach face-to-face, when I have a class on Halloween, and even one before or after, I always bring candy to hand out to my students. And I don't know if I mentioned this, but I always follow Dr. White's golden rule of Halloween candy. And I don't give out candy to people like come to my door or my students that I wouldn't want myself. So I always give the good stuff, Kit Kats. That's my favorite Halloween candy. Hershey's is good too, and Nestle's Crunch I like a lot too. Oh no, I'm already thinking about the good things. My turn. I see everybody's giving me the sign, get to work, Dr. White. So I will. All right, what's different? What's not carbon? What's not hydrogen? I think you got the drill, but it's good to repeat it. Ooh, 2 oxygens to the same carbon. And it's got hydrogen here. That could be our prime, but it's not. It's got carbons here, our double prime. And the oxygens, I have carbons. They're the same. I'll call that R. This is a ketal or acetal, depending on if our prime is carbons or hydrogen. Keep your eye on this carbon with the 2 oxygens, becomes a carbonyl, carbon double bond to oxygen. What's attached to it, R prime, and I apologize, should have put a plus sign there, and our double prime. On tests, I always make sure that I didn't forget to do that. And we also get the alcohol from here. Now, if you want, you can put a 2 there, but I don't. So this is our prime, our double prime, R. Keep your eye on this carbon with the 2 oxygens. It becomes this carbon. Our prime hydrogen, our double prime methyl. So I get this aldehyde. And then my R is methyl again. And for those whom, I don't know, can I write that 2 any smaller? You can put the 2 down, you don't have to. And let me know when you're done checking. Oh, let's do another one. These are fun. And here's another one for you to have fun with. If I say fun enough times, you might believe me, but it is fun. See how sneaky I am? And remember, I'm going over these reactions because historically students have trouble with these. And if I go over them, hopefully you won't. And we'll wait for everybody to finish. Oh, okay. Everybody's finished. I missed the high sign. All right, let's look for what's different, what's not carbon, hydrogen, ooh, oxygen here to the same carbon in the ring. Each oxygen has carbons on it, the same R, and then I have carbons here and here, which I'll call R prime and R double prime. They just happen to be connected together. That could have been a hydrogen, but it's not. Acid, water. Keep your eye on this carbon with the two oxygens, becomes this carbon. And I should have, and I did it again. It's forget plus signs Wednesday. And that will be double bonded to oxygen, carbonyl. What's attached to it, R prime or hydrogen, and our double prime will still be attached. And then the R's on the oxygen become an alcohol. And for those who must, you can put a 2 in front of the R. You don't have to. So let's look at this carbon, which is this carbon, becomes this carbon. What's attached to it, the ring and the methyl group, will still be attached to it. But it will now have a carbonyl or carbon double bond to oxygen. Here is my R group. Therefore, my alcohol will be that. And if you want, you could put a 2 there. It's interesting, in the past, I had students put a 2 there and they put the quotes because they think, oh, it's important to have the quotes. I'm just showing you the quotes. That means it's not necessary. All right, let's continue. Well, first I'll wait until you're done checking your answer. Okay. For those who don't want to do the thumbs up, you can do the head up and down. All right, let's do one more. And Dr. White's smiling big time now because I love Grignard reactions. Oh, by the way, the 4 reactions I just went over, I will never give a synthesis reaction on a test or a final. Same thing with this one. So what do we have? We have a ketone or aldehyde, and we have a Grignard. Remember, X here can be chlorine, bromine, or iodine. And this attacks the carbonyl carbon, opens it up to an alcohol. What's attached to that carbon is still attached. R prime or H, R double prime. But now, and this is why Victor Grignard, Dr. Grignard won a Nobel Prize, you get to do something very special. you form a carbon-carbon single bond. And like I said, this opens it up to an alcohol. And doing that is very rare, very special. And here's one for you to do. Boy, time flies when you're having fun with carbonyl groups. And we'll wait for everybody to finish. All right, I think everybody's done. So I better get to work. What do we have that's different? Ooh, oxygen double bond to carbon with a hydrogen. Could have been a carbon too. And we've got carbons here. Ketone or aldehyde? Well, this is an aldehyde. If R prime was carbons, it would have been a ketone. Then what's different? Oh, magnesium halide. That's a Grignard. Where X can be chlorine, bromine, or iodine. Second step, acid, H plus, water. Keep your eye on the carbonyl carbon. What's attached to it? R prime or hydrogen. R double prime is still attached. And because we have a Grignard right here, we're going to form that something special. Carbon-carbon single bond, and this opens it up to an alcohol. So here's my R prime, R double prime, and R triple prime. Here's my carbonyl carbon. What's attached to it? R prime is a hydrogen, R double prime, ethyl. It opens up to an alcohol, and now I make that very special thing, a carbon-carbon single bond to my R triple prime, and I have a methyl group. And that's how we do it. Oh no, guess what? Well, first of all, let's wait to copy it down. Okay, I just looked at the clock. It's time for a break. Let's see what time it is. Come back at 1:57 by my clock, or 5 minutes from now. I can get up and stretch. That's what happens when you have older muscles and you've been sitting for an hour. See you in 5. I'm back. Sorry I was a minute late. I checked my mail. Got a thing from the state. I don't know if you got one, a postcard saying they got a new program. And for 2021 taxes and everything, they'll give you money back. Not bad. I'll check how much I'll get. All right. You know something? I was just looking out at you people. You look like you could use a pick-me-up. So, all right. It's time for what's a fun pick-me-up? It's fine. Time to play. Circle and name the functional group. Actually, there could be more than one group or groups in the following. Molecules. So it's time to play that fun game. Circle and name the functional groups in the following molecules, 2 points each. Remember, you're not to name it, the whole molecule, just circle and name the functional group. And it's time for you to play that fun game, circle and name the functional group, 2 points each. Hint, look for something different. I hope you're having fun playing this fun game. Circle and name the functional group. 2 points each. And when you're done, give me a thumbs up. All right, my turn. All right, how do you play this game? You look for what's different. Ooh, oxygen. And you don't have to do this part, but I will. Oxygen with carbons on both sides. This is an ether. Ooh, another oxygen with carbons here, here, and here. What do we have? A ketone. Let's move on to the next one. Ooh, oxygen with a hydrogen on a carbon. And that's, well, you don't, hold on, an alcohol. And again, you don't have to write what I do like ROH, but I'm showing you how to identify it. Ooh, there's another oxygen here, and it's got a to this carbon with a hydrogen carbons here. And what is this? An aldehyde. Then in C, I think I threw in everything but the kitchen sink. And what's, ooh, oxygen and a carbon, that's different. What's this? An alcohol. Ooh, another oxygen. It's a carbon here, carbons here and here. What's that? It's a ketone. Are we done? No, another oxygen. I've got carbons here and here. It's an ether. Oh no, one more. Oxygen here. Again, look for it. And we have oxygen, double bond to carbon, hydrogen. Carbons over here are, this is an aldehyde. And that's how you play that fun game, circle and name the functional group. And besides being a fun game, it's important because if you don't know what functional group you're dealing with, how can you name it? How can you know how to react it? All right, let's go back and do one more Grignard reaction. Remember, look for what's different. Ooh, carbon double bond oxygen. This can be if R prime is hydrogen aldehyde, if it's carbon, it's a ketone. And here we have right here, R triple prime MgX, Grignard. X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it? R prime or hydrogen. R double prime is still attached to it. This becomes an alcohol, OH, and then you do that very special thing. You make a carbon-carbon single bond to the carbon with the hydroxyl group. And here's one more for you to try. And don't forget, if you haven't learned it, you can always come to my office hours because the test is coming up a week from today. The method I taught a while back, but I cut out a video, how to eliminate test anxiety. And it looks like it works quite well once you get it down. Got to find a good memory. That's the secret. All right, my turn. Look for what's different. Ooh, oxygen, bond to carbon. Carbon's here, carbon's here. This is a ketone. Could have been an aldehyde, but it's not. Ooh, carbon, carbon, magnesium chloride. That's a Grignard. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. That's where the fun is. But then I'm biased. I'm a carbonyl carbon synthetic organic chemist. And what's attached to it, our prime or hydrogen, our double prime is still there. This opens up to an alcohol, and then you do that very special thing. You make a carbon-carbon single bond to the Grignard, our triple prime. Now, what's attached to this carbon, that was this carbon, is still attached. In this case, we've got the ring. And the ethyl group will still be there. Now, this carbon, which is this carbon, is this carbon, which is this carbon. So I'll have a hydroxyl group, OH, and then what's my R triple prime? The carbon with the Grignard will be the carbon bonded to this carbon with the alcohol. And that's how you do it. Now, if you have the hydroxyl group and the N-propyl group switch, in other words, the OH is on this side, the N-propyl is on that side, that's okay too. Everybody have everything copied they want to copy? All right, like I said, this reaction and the ones I covered today will never have a synthesis problem, but I wanted to cover these again because students have trouble with these, and I want my students not to have trouble with these. And let me remind you that a week from today will be test 2. I'll put out more information about that. So you know what time it is? It's new chapter, new functional group time. And what I'm going to talk about now will not be on test number 2, but will be on 1, 2, 3, test number 3. So what's this new group? What's this new chapter? Uh-oh, hold on. I thought I had that covered. All right, we're up and running again. All right, everybody see chapter 10 on your screen? Thank you. And this new chapter is called carboxylic acids and their derivatives. Now, this is a new word I haven't used this semester, derivatives. That means those are new functional groups that are made from, derived from, that's how you get the term derivative, from carboxylic acid. Now, what's a carboxylic acid? Well, it's a new functional group for you, and it contains a carbonyl and a hydroxyl group attached to the same carbon. And that's how it got from carbonyl and hydroxyl carboxylic acid. Now, here's how you can draw a carboxylic acid. Now, I have it this way, a better way for you is like this. This is a carboxylic acid, carbonyl, carbon, double bond to oxygen with a R group and a hydroxyl group on the carbonyl carbon. And that's called a carboxylic acid. Now, there are other ways of writing it, and you can also write it. I rarely write it this way, and I don't like that, but I will later on in the semester when we go over back again things that make carboxylic acids, write it this way. So you can either write it like this or like this. Both of these are the same. These are both the same carboxylic acid. So, and a lot of times you'll see in books this way because it's cheaper to print it that way. And That's why there are two ways of doing it. Now, let's talk about carboxylic acid nomenclature. And let's get a carboxylic acid up on the board. Now, look at the structure. What's different? Ooh, we've got a carbonyl with an R group with a hydroxyl group. And remember, this material will be on test 3, not test 2. And this is a carboxylic acid. So how do you name it? You find the longest chain with the carbonyl carbon in it and name it as an alkane. 1, 2, 3, 4, 5. And that would be pentane. And you drop the E and add OIC and the word acid at the end. So I drop the E from pentane. I'll add the letters OIC and the word acid. Now, just like an aldehyde, the carbonyl carbon of a carboxylic acid will always be 1. Since everybody knows that, we don't have to put a 1 in there. You can't have a 2, because if you do, you don't have a carboxylic acid anymore. So I'm done. This is pentanoic acid. Now, if you have alkyl groups, you handle them just the same way we always did. And if we look at this molecule, first of all, what's different? Ooh, a carbonyl and with a hydroxyl group, OH, with carbons. And this is oh, I forgot to tell you, this chapter, I'm going to talk about a lot of neat things, including the first chemical reaction I ever did with my hands. When you're born, you're doing chemical reactions in your body. Plus, I'll give you my father's secret to making the best spaghetti sauce. It's a secret, so keep it a secret just between us. All right, how do you name this? What's the longest chain with the carbonyl carbon? 1, 2, 3, or down here would be 3. So that's propane. Name it as an alkane, drop the E, add OIC, and the word acid. So that would be, I drop the E, add OIC, and the word acid, propanoic acid. However, as soon as I say that, I have that spoken for. Are we done? No. Oh, look, it's your old friend, the methyl group. And what carbon is it on? Well, the carbonyl carbon is 1. That's on carbon 2. So that's 2-methyl propanoic acid. And now it's time for you to have some fun. And the question is, What's the IUPAC name for the following? 3 points each. Well, I should warn you, carboxylic acids is an area I worked in for a number of years at one company in the chemical industry, so I know them real good. Isn't it nice to have an instructor who's worked with all this stuff in the real world? You can say no, it's permitted. All right, everybody done? Let's get to work. What's different? A hydrox group on a carbon with a double bond to oxygen, and carbons on that carbon, and this is a carboxylic acid. How do you name it? Find the longest chain, name it as an alkane, drop the E, replace it with OIC and the word acid. So 1, 2, 3, 4, that's butane. Drop the E at OIC and the word acid. And we have butanoic acid. By the way, not to get you grossed out, but I will. Butanoic acid smells like upchuck, if you know what I mean. It's one of the most foulest non-sulfur chemicals I know of. All right, let's do another one. That's 8 carbons across. And what would be the IUPAC name for the following molecule? And we'll wait for everybody to finish. Everybody's finished, so we don't have to wait. And what's different? Ooh, hydroxyl group, 2 oxygens, carbon, carbonyl hydroxyl group. This is a carboxylic acid. Remember, find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name it as an alkane, drop the E. And replace it with the letters OIC and the word acid. Well, longest chain, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8. 8 is octane. Drop the E, add OIC, and the word acid. When I say that, that's spoken for. Oh, look what we have left over. My favorite, and that's the T-butyl. If you wanted to write tert-butyl, that's okay. T-butyl. And what carbon is it on? Carbonyl carbon and the carboxylic acid. It's always 1, so that's 2, that's 3. So it's 3-T-butyl octanoic acid. Now, there are 2 types of nomenclature questions. The second type, first type is give the IUPAC name. And how do you do that? You start from the left, right, and move left. OIC acid tells you have a carboxylic acid. And if that were an E, instead of OIC in the word acid, heptane, 7 carbons. Now, I always write my carbonyl on the right. You could do it on the left. I don't. Good habits I don't break. And it's a carboxylic acid. I have my hydroxyl group and carbonyl. And I know there are 4 bonds to carbon. And I'm done. And if there were an alkyl group there, I'd put it there. So why don't you draw the following molecule? And we'll wait for everybody to get done. Everybody's done. Okay. How do you decode this, know what to draw? You start from the right, move left. OIC acid tells you it's a carboxylic acid. And if that were E instead of OIC, hexane, 6 carbons. And the N carbon, you can do right or left. I always do right. We'll have a hydroxyl group and a carbonyl. And I put in my hydrogens because I know there are 4 bonds to carbon. Oh, let's do another one. And why don't you draw the structure for 2,3-diethyl nonanoic acid? I think I spelled that wrong. No, I got it right. It's just let me write it clear. That's better. Thank you. And we'll wait for everybody to finish. Everybody's finished. So my turn. And how do we decode this to know what to draw? You start from the right, move left. OIC in the word acid tells you have a carboxylic acid. And if this were an E instead of OIC, that's nonane, so that's 9 carbons. And at the end here, I'll have my carboxylic acid. You could also put it on the left. I don't. Now, ooh, look, I have not one, but 2 ethyl groups, because I'm still going this way, and they're on carbons 2 and 3. Carbonyl carbon is 1, 2, 3. I'll move it this way so I have enough room to write it. And now I know there are 4 bonds to carbon, so you get to watch me put in all the hydrogens. And remember, it's your solemn responsibility that if I make a mistake in the number of hydrogens, you let me know. And here we have 2,3-diethyl nonanoic acid. And that's how you do it. And I'll wait until everybody checks their answer. Everybody finish? And if you notice, I just went through this, find the longest carbon chain that includes the carbonyl carbon of the carboxylic acid. Name that as an alkane. You drop the E at the end of A and E. Notice I got colorful on my slide, and add OIC in the word acid. The carbonyl carbon is always number 1, and name and number all the substituents as per what we've always done. Now, this I've never encountered in my career, but I put it down. I will never put this on a test. When the carboxylic acid group is attached to a ring, and it should be non-aromatic, the ending carboxylic acid is added to the name of the cycloalkane. I've never worked with that, so I'm not going to do that. Now, there's some common names I would like you to know. Hint. And those are names that people use instead of IUPAC names. They never do. And the first one is formic acid. It turns out, remember, carboxylic acid has the structure. Now, formic acid, turns out R can be hydrogen. Nobody calls that methanoic acid, which would be 1 carbon methane, drop the E at OIC. It's called formic acid. Now, how many of you have ever heard of the fire ants? And those are ants, thank God they're not in Illinois. Hope they never will be. But anyways, Those are ants that, as a defensive weapon, sprays a liquid on their attacker. And if you ever get it, which I never have, and I hope I never see a fire ant, it burns your skin or the animal and it drives them away. Well, what is that spray? It's a mixture of hot water and formic acid. Carboxylic acids, certain ones, if you get on your skin, will provide what's called a acid burn. If you ever get concentrated mineral acid, don't ever on your skin. I have never, but I've unfortunately seen people who have. It burns just like if you put hot metal on your skin. Do not try that at home. That's formic acid. Now, the next one is acetic acid. And all of you probably have that in your house. You're going to say, wait a second, Dr. White, I don't have acetic acid in my house. And I'm going to say you probably do. First of all, the structure of acetic acid is when R is a methyl group. The IUPAC name, ethanoic acid, because 2 carbons ethane, nobody ever uses. It's acetic acid. Now, why would I say acetic acid is in your house? Because if you take about 4% acetic acid and about 96% water, mix it together, you get a homogeneous solution, which we call vinegar. And you all have vinegar in your house, or if you have ketchup, the ketchup has vinegar. If you have mustard, the mustard had vinegar. Isn't it amazing? We're getting into all the condiments of hot dogs, and pickles have vinegar in them. And that's acetic acid, because vinegar is 4% acetic acid, approximately, and the remainder water. And if you like, there are different types. You can get wine vinegar. You can get rice wine vinegar. My favorite is a brand, Japanese brand called Marukan, and that's really good stuff. Now, let's go to benzoic acid. Now, benzoic acid is a common name that also became the IUPAC name. And that's when the R group is a benzene ring. And as you've seen before, IUPAC in their infinite wisdom, and I mean that sincerely, we're not going to get those organic chemists to change something they've been calling for eons. We'll adopt it as our official name. So that's benzoic acid. Now, when it comes to common names, I will never ask what's the structure of this common name of a molecule, but I'll ask you to draw it because you'll see these in labels and they're commonly used. All right, I'm going to turn the switch. Will this be on test number 3 off? For test number 4, we'll come back and learn some of these. And there are other common names for carboxylic acids. And when there's 12 carbons, that's this plus N plus this carbon equals 12. We call that lauric acid. When there's 16 carbons, this carbon N, which is the number of CH2s plus this is 16, it's called palmitic. And when it's 18, stearic. When it's 18 with a double bond, oleic. And I worked for a company that made oleic and stearic acid. In fact, I invented 2 different new types of oleic acid years ago. They're still being sold. We'll come back to this. Now, switch is still off. There are 2 more acids, carboxylic acids, I'd like to talk about. Why? Because these are in your daily life. Again, switch is off, click. One is lactic acid. And like you learned for ketones, on the alpha carbon, there's a hydroxyl group. So this is a common name. And this is molecule that has both an alcohol and a carboxylic acid. Now, how many of you have ever worked out real hard and all of a sudden you got that burning sensation in your muscle? Well, that's because your muscles make lactic acid. I guess that's nature's way of saying slow down for a little while. And that's lactic acid. And I guess it gives you a slight burn in your muscles from being a carboxylic acid. Now, I'm going to talk about something right now. I hope I don't offend anybody. Ooh, what is he going to talk about? But one of the things I like to do is look at products, things that have chemicals in them, and wonder, how do they do that? Now, a while back, I happened to be I saw it on TV as a commercial a long time ago, but I happened to be I think I was in Walmart, and I happened to see a product that's a personal lubricant. And that personal lubricant is used for certain personal activities. I'll let you figure out what I'm talking about. And the one they were selling was a product called warming lubricant. And when you used it in that personal activity, it warmed a certain personal part of your body. How did they do that? So I picked up the bottle or a box and looked at the label. No, that's not it. At the very end, I saw it had lactic acid. And what it did was give your certain personal part of your body for that personal activity a very mild acid burn. And that's how it gave it a mild burning or warming sensation. Now, they've since changed the formula to take that out and put a different thing in there that because of certain alcohol, when it hits the moisture on your skin, it causes, due to hydrogen bonding, a slight exotherm heating. But Dr. White likes to do that. I'll talk later in the semester how they did the product fire and ice, same personal type of activity. Now, the other molecule, again, switches off is citric acid. And I have it drawn here. My software didn't want to do certain things, but you could also draw it like this. Switch is totally off. And if you notice, this molecule has not one, not two, but three carboxylic acids and an alcohol. And this is citric acid. How many of you have ever bit into a lemon and you go, ooh, is that, that's strong. It's a bitter taste. Ooh, that's really sour. Well, what's doing that to your tongue and your brain is this molecule, citric acid. In lemons is citric acid that gives that sour taste. By the way, citric acid is a solid at room temperature, but obviously in a lemon it's in with the water. Now, limes also have citric acid, but there's less citric acid. So you don't get that sour as much, but it still has a sour taste to it because there's more citric acid in lemons than limes. Now, how many of you are familiar with, I think it's been about last 5-10 years, there's a trend in children's candy. The more sour, the more they like it, which I wouldn't like, but I'm not a child anymore. Maybe, but no, I'm not. But anyways, they've just put more citric acid in there. And because it's a solid and now made synthetically by chemical reaction, if I wanted to, and if I had the credit and the credentials, like I had my own company, I could pick up the phone, call a company, and have 50,000 pounds of citric acid delivered to my company to use for whatever. Now, a couple of years ago, I saw this one company I like to buy from, the Spice House, was selling pure citric acid. So I bought some, and when it came, I wonder how sour is this? I went like this, tasted, wow, that is sour. This was 100% citric acid. Gotta be careful around certain things like food when you know chemistry. Now, today, as I mentioned earlier, we're not doing a lab because I got a week ahead of myself. So this way we're catching up. And because of that, I'm done for today. Unless you come by my office hour tonight. And if you have any questions, come by. If you need any help, come by. Or if you just want to say hello to Dr. White, you can come by too. But if you're not, I'll see you on Monday. Remember, a week from today will be test number 2. So make sure you've been doing the problems. And also, I will put out before Saturday. I'll have to write a note to myself, make sure I do that. If I don't, send me a mean email. You promise, Dr. White. I'll send out an email and put an announcement for the of how many pages, areas covered, which I've already mentioned today, and point breakdown for test number 2. Don't forget on Monday, I will go through the aldehydes and ketones problem set. I'll also do my world famous review for the next test number 2 in this case, and we'll do other stuff. We'll get back to carboxylic acids. And with that, I'm done. Have a nice rest of the day, rest of the week. I'll see you on Monday or tonight if you come to my office hour. And with that, I'll say, Gang gesund, which is Yiddish for going out. And I stole this from Granny of the Beverly Hillbillies. Bye, Gang gesund.